So for this next example, we're going to prove that for if r is a real number and r doesn't equal 1, and we have that n is an element of the positive integers, we have that 1 plus r squared plus plus r to the n equals 1 minus r to the n plus 1 over 1 minus r. Okay, that's a little bit complicated. Let's walk through it. So if I am going to use induction, because I am. Okay, so I like the word since. Since, if I let r equal 1, I'm going to have this. So it's going to give me 1 plus r equals 1 minus r to the 1 plus 1 over 1. That's going to give me 1 plus r equals 1 minus r squared over 1. 1 minus r. That equals 1 minus r times 1 plus r over 1 minus r. My 1 minus r's cancel, so I find that 1 plus r equals 1 plus r. So because this is true, now we can show since this is true, for n equals 1, we can assume that for some k that's a positive integer, we have 1 plus r squared plus r to the k equals 1 minus r to the k plus 1 over 1 minus r. We must show this is true for k plus 1, and that we find, I always like to write what I should get to, because then we know we have a goal. 1 plus r to the k plus 1, we're not writing everything, equals 1 minus r to the k plus 1, but it's add 1, so that'd be k plus 2 over 1 minus r. So let's go ahead and start proving this. So we have that it is true for k. So I would go ahead and write my k step. So I have 1 plus r squared plus r to the k equals 1 minus, gosh, I have room for this, r to the, hi Bobby, k plus 1 over 1 minus r. She's just excited we have a new president. Aren't you, Bobby? Yeah. Okay, so we're going to go ahead and add r to the k plus 1 to both sides. You don't have to write in the proof what you're doing. That's why when I write it in the proof solutions, I put it in pink. You don't have to write what you're doing. I do to help you guys. I also does help me remember eventually what I did. So I've got 1 plus, I'm going to use parentheses. Look at that. I don't have to write all the things. Equals 1 minus r to the k plus 1 over 1 minus r plus r to the k plus 1. Okay. Now, I need to rewrite this so I can combine these two. So I'm going to have to make this here a fraction. I'm going to make it a fraction by multiplying by 1 minus r. Ooh, that doesn't look very clear, sorry. By multiplying by 1 minus r on the top and 1 minus r on the bottom. I can then go ahead and add these. That gives me 1 minus r to the k plus 1 over 1 minus r plus r to the k plus 1, but let's go ahead and distribute that. So that's r to the k plus 1. And then r to the k plus 1 times r, which is r to the 1. When we multiply exponents, we add their powers. So now I have k plus 1, which it gives me minus, back to the eraser, minus r to the k plus 2. Okay, look, these middle terms are going to cancel. So I'm going to have this equals, we're going to write it up here because there's no room, my quotation marks equal, the quotation marks over here, equals 1 minus rk plus 2. Oh, it's so tiny. I need so much more room. Okay, this equals 1 minus r to the k plus 2 over 1 minus r as desired. Thus, we have proven this second example. Here is the solution, all typed up very nicely. Okay, so you can see what we're doing.